We also have the likes of our CMOS automatic system available on our Lexion machines as well. With the CMOS system selected, it's an automatic system which is working in the background to adjust the likes of your operational settings to the fully optimized at all times. So for example, if I'm cutting for a very long day and I know that I'm not going to be adjusting the likes of my drum speed and concave continuously through the day, the automatic system will pick up the slack in the background and will then be adjusting the likes of my drum speed and my concave, for example, for the best optimization of the machine. I can then change the machine optimization settings to work exactly as I want them to work. So again, the machine automatic systems, or the CMOS automatic systems, are there working in the background to fully optimize your machine at all times. The CMOS system works in a number of different ways, and we have a number of different systems available to us. We can see here on the main automatic screen that I've got a few various A's located around the machine. So I can see here, being a straw walker machine, that I have an A system, which means I have CMOS threshing. I have an A system, which means I have CMOS cleaning, and I also have a chopper system on the machine, so I can have CMOS chopping. One system I don't have on this machine is CMOS separation. This is because it's a straw walker machine and not that of a hybrid machine. However, if I did have a hybrid machine, I would see CMOS separation also available. Again, this is an optional feature which will depend on the specification of your machine. The way these systems work is currently I can see they are turned off because none of the lights are highlighted and my threshing is not engaged. However, with my threshing engaged, I can then press the A, the auto button on that of the joystick, and these will then light up the individual icons, meaning that my CMOS system is then fully engaged and working in the background. First, we're going to take a look at the likes of CMOS threshing and how the CMOS threshing system is working. Now, again, I can turn this on and off through the joystick, but if I individually want to turn this section off, I can click on the system and turn my automatic threshing system off, meaning that my other systems will still be enabled, but I can then set a set value for that of my threshing system. With the system turned on, the system is then going to be looking at the likes of my drum speed and my concave gap, my pivoting concave bar, and my pivoting concave flaps. So these adjustments of all these speeds or various machine adjustments will be made automatically depending on the strategy that I have set. I can then go into the likes of my CMOS cleaning, whereas this is adjusting the likes of my sieve, my upper and lower sieve gaps, and that of my fan speed as well. And then finally, CMOS chopping is adjusting hydraulically the movement of my stationary chopper knives and my stationary fine chop step. So for example, if I wanted a finer chop quality, I can optimize this in the screen. So for example, if I wanted a finer chop quality, I can bias it towards finer chop quality. Or maybe if I want to try and save some fuel consumption, I can bias it towards my save fuel consumption as well. So we've seen the various sections available on my CMOS screen, the CMOS settings and how they're being adjusted, be that through the threshing, the cleaning, or the chopping units. And again, on the hybrid machines, I also have separation area available to me too. So as our harvest day continues, our machine settings are obviously going to be adjusting as the day goes on. Machine settings will be different in the morning as they are to the late afternoon. So then as the machine is adapting through the day, the Lexion machine has various monitors throughout the machine to then visualize or see how the machine is performing. I will be able to see the likes of my loss monitors raise up and down. I can see the likes of my return monitors also raise up and down accordingly. The way the CMOS system is working is it's taking all of these available values and making the best predicted adjustments for you. Again, this will also be in conjunction with the likes of our clean grain elevator cam or the grain quality camera, which will then display an icon image of how the grain quality camera is working and what quality of grain we have coming into the tank. So we'll be picking up the likes of chaff or any cracked grains, for example. Again, this is another sensor which is working and how it's being used in the CMOS system. The way I adjust the system or the strategy for my CMOS system is very easy as well. I can go in one of two ways. I can click in to my CMOS icon at the top here and then click Optimization Strategy. And this will list the various optimization strategies I have available to me as a CMOS system. We can see here I can either bias it towards smoother threshing of my threshing system, improved threshing, so maybe more intensive threshing, I can bias it towards grain cleanliness and chop quality. So if I am chopping and I have automatic chopping enabled, I can bias my chop quality. If I don't have automatic chop quality enabled, I can bias it towards straw quality, so if I'm swathing. Again, it's very simple and easy to adjust my strategy. If I'm harvesting and I feel like I need more intensive threshing, I need to improve that of my threshing system, I can bias my CMOS system towards improved threshing. This works on a 2-bias screen, either 1 incremation or 2 incremations, 0 being normal positioning. So for example, with improved threshing, it's more likely that my drum is going to run a bit faster, my concave is going to be a bit tighter, and maybe it's going to enable the likes of my concave pivoting bar or my concave pivoting flaps. For the likes of grain cleanliness, it's going to be adjusting my sieve and my fan options as well. So if I find maybe my grain tank sample is a bit dirty, I can bias it towards grain cleanliness, and that's then going to be biasing the likes of my sieves and my fan unit to then give me a better quality of grain. Again, I can do multiple settings at one time, and this is then going to be working the system in the background, the CMOS system, to best benefit the system I have selected. So I can either select my optimization strategy to bias towards that of any of these performance qualities, but I can also bias my performance quality towards output. So if I increase my output or my throughput setting, I can bias my strategy the opposite way. Now this is going to be increasing the throughput or the output of the machine itself, but it's going to be taking away to some extent the values I see here on the left-hand screen. So for example, if I'm happy with the quality of the threshing from my threshing drum, I can bias my CMOS settings towards throughput. This is then maybe going to run the drum a little bit quicker, but maybe run the concave a little bit wider so it can force more crop through the concave itself, therefore increasing throughput. Again, with improved grain cleanliness, if I'm happy with the sample coming through into my grain tank, I can bias towards increased throughput. What this is going to do is maybe open my sieves a little bit wider, and also then increase or maintain that of my fan speed, so that I've got a wider sieve I can maintain then crop in through the sieve itself. Finally, I can also bias that of my chopper quality. So if I'm happy with the chop quality I can see coming from my machine, I can bias it towards the reduction of fuel consumption, and this is then going to maybe reduce that of my stationary chopper knives in my chopper system, and then remove the fine chop step as well. So the system acts a lot more normally and is not as intensive or aggressive as if it was towards chop quality. This is then going to save that of my engine horsepower and then in turn reduce that of my fuel consumption. Again, we've got various optimization strategies available here at Claas for our CMOS systems. We do suggest when adjusting these optimization strategies that we do one at a time, so that we can then optimize the strategy, see how the machine reacts, and then if we feel like it needs further improvement, we can then bias it accordingly, so we're not adjusting too many machine settings at one time. As my CMOS strategy is adjusted throughout the day, we can see signs of this in the screen itself. So, as the day goes on, you may at certain points see the likes of your loss monitors shoot up, but these will be grayed out bars. They won't be the normal blue bars that we're used to, they'll be grayed out sections. And also at the same time, we may see a little turning symbol of that of our automatic system. This means that our CMOS system is trying to refine or trim down the settings on our machine by making adjustments and seeing how the machine reacts. So for example, if throughout the day I see my machine making the likes of adjustments and settings, and the settings are seen to be an improvement on the system, then the machine will maintain those settings. If it then sees a decline in the likes of the machine settings, it will revert back to the original setting. So again, you may see the likes of your loss monitors peak at certain moments of the day, but these will be grayed out bars and will also be seen by a turnbuckle system. Then if the system sees the improvement, it'll maintain the settings, or if it sees the decline in the system settings, it'll return them to what they previously were. A final setting that we don't have available to us on this machine, but available on the hybrid machines, is that of automatic separation. Auto separation is adjusting that of my rotor speeds and my rotor cover plates underneath the rotors themselves. So, with the likes of CMOS separation enabled, I will have 4 rotor cover plates available to me. The CMOS section will then be adjusting these rotor cover plates as the day goes on, depending on the loss amount or the quality amount in the machine itself. So if I wanted increased threshing in my system, then I know that my rotor speeds are going to be slightly higher than what they would be on a normal mode. Again, this is an automatic system which is displayed with the A icon, and it can be enabled or disabled the same way the other automatic sections are adjusted. On the main screen, if we have CMOS chopping enabled, we can see a readout for the straw moisture. This is taken by a moisture meter found in the underneath of the feeder house and the front of the machine, and this is reading the straw moisture quality, so we can, as an operator, see the moisture sensor of our straw. Obviously, the higher the sensitivity or the higher the moisture of the straw, this is then going to enable the likes of our CMOS chopping options, the likes of our stationary knives and our fine chop step, to then maintain that of our straw chop quality. However, obviously, if the moisture is lower, if it's a drier day, the straw is drier, then it's more likely that the stationary knives and the fine chop step will be removed, as it will be easier to chop the straw itself. Again, this is a constantly maintained system, and we have a constant display of what the moisture setting is doing. This is just for that of the CMOS chopping option. There is also one final learning setting I can adjust for that of my CMOS or my automatic section, and that is that of the learning inclination monitor. Now, if I'm adjusting any of the tyres on my machine, be that rear tyres or front tyres if I have them, then I need to relearn the inclination on a piece of flat ground so the machine knows exactly which angle it sits at when on flat ground. This then aids the likes of our 3D and 4D systems.